Hello and welcome again. In the next few sections, we're going to be talking more about solving more complicated polynomial equations, specifically quadratic equations, and we're building up the tool set that we need in order to solve those things. Our first step is to start talking about greatest common factors and factoring in general. But let's start by reminding ourselves what quadratic equations are. A general quadratic equation has this form: ax squared plus bx plus c equals 0. And setting that equal to 0 is basically equivalent to solving or determining the x-intercepts of a quadratic function. Imagine we've got y equals ax squared plus bx plus c. A, b, and c are just numbers. So a, b, and c are just constant coefficients, and when you plot this plot the graph of this equation, you get this parabola, and the x-intercepts of that, these guys here, are when the y value is equal to 0. So we call those x-intercepts or roots of the function, of the quadratic function, or zeros of the function. Now, in order to solve this, we need a tool, and the tool we're going to use is this principle of zero products. It's not a fancy principle. The principle of zero products involves basically this idea that if you have two expressions that are multiplied by each other and they equal 0, what can you say about those two expressions? Well, either A is 0, either one of them is 0, or the other one is 0. They could potentially both be 0, but at the very least, one of them has to be 0 in order for their product to be 0. How we'll use this principle is by factoring the quadratic. For example, say you had this equation here, and if you multiply this out, you will find that this is indeed a quadratic equation. But just these are already factored. They're already written as a product. So basically from this, we know that either this expression is 0, x plus 3, or x plus 1 is 0. And from that you get these two mini equations where you solve these mini equations and you get two separate solutions. So this might sound familiar. When we had x squared equals 16, say, we would know that you take the square root of both sides, you need a plus or minus square root of 16, which would be 4. So our goal here is to learn how to factor these guys. If you multiplied this equation, these two binomials out, you would get the quadratic x squared plus x plus 3x 4x plus 3. And our goal is to go the opposite direction. Given any kind of quadratic equation, can we go backwards, or in some sense, and split that quadratic into the product of two things? Now, the first thing we have to learn about factoring, though, is factoring out a common factor. If there's a common thing, a common factor in all terms, normally we want to factor that out first. So let's talk about the greatest common factor. Or GCF. You might also see this referred to as the greatest common divisor. Factors are things that are multiplied together. Just like terms are things that are added together, factors are things that are multiplied together. Say we have a problem asking us to find the greatest common factor of 45 and 63, say. So let's break this down. Factor means something that goes into a number. Common factor means something that goes into both the numbers, or all the numbers. Greatest common factor means the biggest number that goes into both these numbers. For example, 3 goes into both of these numbers. 3 times 15 is 45, and 3 times 21 is 63. So 3 goes into both of those. But we can do better. We can find a bigger number, and that's 9, of course. 9 times 5 is 45, and 9 times 7 is 63. So the greatest common factor would be 9. Let's look at another example. Let's find the greatest common factor between these two. Well, 2 goes into both of those, but x also goes into both of those. So GCF, the greatest common factor, is 2 times x. It's the number that goes into both of them. If I wanted to factor them out, factor both of them, we would write 2x times what's left over, the x. Basically, you just divide what's here by the thing you're factoring out. You're factoring. 4x divided by 2x is just 2. So here's our common factor. 2x goes into both of those. And what's left is x and 2. Now I'm writing it this way because it's just a quick step to go from here to factoring out a common factor, the greatest common factor, from something that has several terms. For example, what if these guys were in a expression where they were just added together? If our job was to factor this, then we would look for a greatest common factor, which is 2x, and we write it on the outside. And then what's on the inside is just what's left over, just like what we did over here. X plus 2. We take each of these terms and divide them by the number that we're factoring out. In some sense, we're undistributing, right? Because you could distribute this back through and verify that, yes, this is the same expression. And you can easily bring this to a potential case where, what if you've got an equation? 2x squared plus 4x equals 0. You can't solve this by getting your x's by themselves because you've got two different terms that aren't like. You can't combine these two terms. So the goal is to get everything on one side and then factor. If you factor this left side, you get 2x times x plus 2 equaling 0. And what does that tell us? The product of 2x and x plus 2, or if you like, the product of 2x and x plus 2 has to be equal to 0, which means one of those three things is 0. If either any of those three things is 0, then we have a solution. 2 is never 0, so you can ignore it. X, either x is 0, or you could have written 2x equals 0 here. It would have been fine. And then divide by 2. Essentially, x is 0, or x plus 2 is 0. And then we solve this little mini equation, and you get x equals negative 2. So the solutions of that equation are x equals 0 or x equals negative 2. So that's how we're going to use this. First, let's look at some more examples of factoring out the greatest common factor. Now let's start simple. This is a problem from the homework. If I want to factor this, you need to find something that goes into both terms, the most that goes into both terms, in this case it's 4, and then undistribute it, and what's left is each of these terms divided by what you're going to pull out. So 8n divided by 4 is going to leave you with 2n. 12 divided by 4, negative 12 divided by 4, is going to be negative 3. And that's it. So first identify what the common factor is, the greatest common factor is. If you'd like to write it down, you could. The GCF here is, well, look at the coefficients first. What's the biggest number, actual constant that goes into both of these coefficients? 6 goes into both of those, right? So we've got 6. And now look at the variables. X goes into both of those. X squared goes into both of those, right? Because you've got a factor of x squared here and a factor of x squared here. But you don't have a factor of y in both of them. You just have a factor of y in the first one. So it looks like we just have x squared that we can take out of them. So that's the thing that we'll undistribute, 6x squared. And you'll find out what's left over by dividing both of these by 6x squared, if you like. Now it's important to think of it that way because if one of the terms is in fact the greatest common factor, you'll be left with a 1 there. So what's left? So we got 2xy plus 1. And if you want to check that you factored this correctly, distribute it back through. And we got 6x squared times 2xy gives you 12x cubed y plus 6x squared plus 1 is 6x squared. Now note if we had forgotten to put that 1 there, we would have just have 12x cubed y, and we would have lost that last term. What about this one? 13x to the 5th minus 9. What's the greatest common factor between those terms? Those two terms? Yeah, there's nothing here. There's nothing goes into both of these. Either in the constants, there's no common factor, and the x's, there's no common factor. So this is factored. Or there's no common factor, I guess we could say. Here's another one. Yeah, let's look at a little harder one. M squared n to the 5th. This is also on the homework, or something like this on the homework. 4m squared n to the 5th. 36m squared n. Okay, let's find our common factors. 4 goes into both of these, both terms. M squared goes into both terms. And n, can't get all 5 n's, but we can get 4 of those n's. And what's left over? Well, 4m squared n to the 5th divided by 4m squared n to the 4th. So we're left with n. If we divide by 4m squared n to the 4th here, the m squareds and the n to the 4th all cancel, and you just get 36 divided by 4, which is 9. And that's it. Now, obviously, you could have more than just two terms, in which case, whenever you factor out, it has to be a factor of all the terms that you're factoring out of, not just some of them, unless you're grouping them for some reason, which we'll get into in a second. Let's look at 80x cubed minus 16x squared plus 8x. Now, when we're trying to solve, like if this is set equal to 0, our first step would be to factor out any common factors, factor out the greatest common factor, and then see what's left over that we might be able to factor further with other tools. Well, what goes into all three of these? It's like 8 does in our constants, and x goes into all three of these. So let's take out an 8x. What's left over? 80x cubed divided by 8x. If we undistribute and pull out that 8x, we are left with a 10x squared. You can check it real quick as you're doing this by multiplying those. 8x times 10x squared is 80x cubed? Yes, okay, good. Minus 16 divided by 8 is 2. X squared divided by x is x. Notice I'm not writing them here. For a while, if you need to, just write them. Divide by 8x. You could do this all right here, in fact. You could have another step. 8x, 80x cubed divided by 8x minus 16x squared divided by 8x plus 8x divided by 8x. You could do that and then go to this step. So this might be an intermediate step. 2x plus 1. So there we go. And you can get quicker at this as you do it a lot. Got one more thing here to talk about. Let's talk about factor by grouping. If you ever have an expression that has 4 terms in it, you could try to factor by grouping. If you don't see something that goes into all 4 terms, you can maybe take them in pairs and see if that gives you something. This is just something to try. This is a tool in your tool belt you can try. For example, let's factor x squared plus 5x plus 3x equals 15. Now, that 5x and that 3x could be combined because they're like terms. But I'm going to keep them separate just to demonstrate how this works. So you could factor them by taking them in groups. Look at these two and look at these two. So first, let's find a common factor just in the first pair. Well, x goes into both of those. So let's factor an x out of those. You're left with x plus 5. Now with the second pair, I can factor out a 3 out of both of those terms. And I'm left with x plus 5. How about that? Now the cool thing here is these two are the same. Now we have two big terms here, this one and this one, who have a common factor of x plus 5. So we could factor that out of these two big terms. When I do that, I'm left with x plus 3. And that's it. Okay, so let's look at one more example. Okay, so we're going to factor 21x cubed minus 3x squared y plus 7xy minus y squared. This looks pretty daunting, right? First of all, look, see if there's something that goes into all four terms. You'll see that there's not much to work with there. So let's look at this pair. 21x cubed minus 3x squared y. So what goes into both of those? 3x squared. Looks like that's it. And then we're left with 7x minus y. Now, as I factor this second pair out, I want to be looking for a 7x minus y. If I don't get a 7x minus y on the inside, then this won't factor. So let's see if we do that. Well, what goes into both of these? Y does. I think that'll help. That'll work. Then we're left with 7x minus y. So you see we got a 7x minus y in both of these. So we're good to go. We can do that second step of factoring out the 7x minus y. If you'd like to write it first, 3x squared plus y is what's left over. You just see what's left over is just that 3x squared and that y. That's it. And so this is that 4-term crazy looking polynomial was factored into these slightly less crazy looking binomials. I think that's all I have to talk about right now. See you next time.